So hi everybody, just a logistic thing. This is the first time we've used GoToMeeting for this one, and we're learning a few of the nuances about it. So if you're not able to see the entire slide right now, which has a number of bullet points on the right, a graph, and the word agenda on the upper left, you need to do a scaling of the screen to get it to fit your screen. We had problems with this a little bit ago. So if you need to scale it, Hillary, can you review really quickly how you got that done? Oops, Hillary might have left. Kent, how did you scale it? Okay, go ahead, Hillary.
Oh, no, I'm here. Yeah, so if you hover over the right-hand side of your screen, you'll see a camera button, a plus sign, a percentage, and a minus sign. Hover over the percentage, click it, and hit scale to fit, and you'll be able to see all of the presentation.
Thank you, Hillary. So let's go ahead and get started. We're going to dive into just what we're doing today and then do some introduction on the next slide of who your presenters are today. We're going to really quickly review the changes in the code and dive into these sections that are listed here: the shell and air infiltration, heating system, ducts, water heating system, solar and appliances, and then give you a recommendation or some options for how you can get to the 6 points in the most cost-effective way. And then talk about some of the tax advantages, incentives, and rebates that are available to you that are good for lowering the cost of some of these high-performance homes. And then also talk a little bit some marketing advantages. The chart on the left kind of shows you one of the main drivers behind this is the amount of energy consumption used has been dropping over the last half decade, and there's an emphasis on continuing that work to be done. If we can drop the amount of energy being used, it means that we don't have to build as much on the power generation side, and so there's a lot of incentive to push a less consumption rather than increasing the production, and that's been the goal for a while now. Also from a logistic point, we do have the phone muted, but we do want to take questions as we go through. Some of them we'll deal with right then. Others we might wait until the end. We want to take those via chat. So if you have anything, please enter it in the chat session, either to myself or Kent, or if it's a logistic thing, please contact Hillary. And we should be good to go at that point. So who we are. My name is Garen Thatcher. Along Kent Mitchell's here as well. He's my business partner. We own Swiftsure Energy Services. We're an energy rating company. We're based out of the Vancouver area, but we also have offices in Tacoma. And we've been involved in kind of putting together some classes and work around the new codes for just over a year now, trying to educate folks like yourselves in what's been coming up. And of course, now that we're a day into the new code, we're definitely getting a lot of interest, and that's why today we've got 70 people in this, and we're going to do another one next week as well. So if there is more need after that, we'll continue to do these. So that's kind of where we're at. So we do ratings, code testing for blower door, duct tests, a lot of consulting, modeling, things like that. Kent, do you want to say hi and introduce and just let everybody know you're here in your voice?
Yeah, so I'm mostly on the technical side of this. Looked and done a deep dive into the codes, trying to figure all this out. We probably don't have all the answers, but we could have a lot of them. And let's just roll with it.
Yep. So all the energy rating companies like ourselves that do ratings, any of us or Swiftsure in specific can be kind of your guide to help you simplify some of these code requirements. We're also there to help you reduce risk and reduce the number of errors. We're kind of a third party to really help you build a better house. So that's kind of where we're at and where we sit. What we're going to talk about today is this. So the code has an interesting comment right embedded into the code. It says this code is intended to provide flexibility. Well, every time we add flexibility to anything, it also can offer a lot of complexity. And so that's what our goal is to do, is see if we can reduce some of the complexity of this flexible code. We are going to be talking about residential single family, and we're talking about the energy code changes. So we're not talking about the other areas of the code that went into effect yesterday. Out of scope will be commercial or large multifamily. We're not going to be talking about the remodeling space or retrofit. We're also not going to be talking about any of the politics surrounding the on again, off again, and kind of delayed rollout of the code over the last year and a half. Aladet with the BIAW is offered to take your questions if you have political questions about how the BIAW was involved. We're not going to deal with any of that in this session. So again, we're really trying to work this tug of war between the complexity and flexibility of the code, and that's what we're hoping to get through today. So quick overview. So let's dive into it. The code requires on the left, there's 3 tiers of code compliance for this. If you're building less than 1,500 square foot home, you are only required to get 3 points. If you're between 1,500 and just 1 foot short of 5,000, you are required to get the 6 points, and that's where we're going to spend the bulk of our time today. If you're over 5,000 square feet, you are required to get an extra 7 point, an extra point, and we can help you do that. But the bulk of this presentation today is about what most people are building, what most of the houses are, is between 1,500 and 5,000 square feet. We did have a builder recently come to us and ask us about through this, and they were building right in the 1,550 to 1,600 square foot homes. And they made the decision to just say, going forward, they were just going to take enough square feet out of the puzzle to get below 14, get to 1,499, and that would allow them to do this 3 points. So there has been an interesting element. There's a big, huge jump between a 1,500 square foot home and a 5,000 square foot home, and all of those require the 6 points. Each of the sections, so there's 7 sections of where you can get points, and you can't go after any single component and expect to get your 6 points. So there's 3 points possible out of shell, 2 out of air leakage, and so forth down this column. So that's why it really takes a holistic look at the entire envelope and the shell in order to get these points, because you can't go to just one trade and say, solve this for me. You've got to go to multiples, and that's where folks like us can really help you. And that's why we kind of looked at this from a top of the whole house view.
So a little clarity on that part too, on this section. So there's the 7 sections. We used to be able to double dip in certain sections, but take a couple different points out of different sections. In this code cycle, the only one you can take a second point out of is the water heating. You can do the drain water recovery. We'll cover that. And section 3 kind of has a double dip. It's got a secondary table that you can get some extra points out of. But other than that, you have to take just one choice from each section.
Correct.
We'll cover
Good.
all those in more detail.
Yep, thanks, Kent. Good add. Okay, so some caveats. The cost estimates have been provided by BIAW and NIA. So we're going to, as we go down through here, we're going to list out how much this will cost you. we're saying that's just a placeholder. BIAW has done some good research over the last year and a half. NIA has done some good analysis of going out to builders who have already made the decision to build up to the new code level over the last several months and have gotten some updated costs. And we've tried to reflect those costs in the tables as we go through. Please recognize that these costs may be obtained by builders who are large production builders and they drive a smaller margin with their subs. So you need to really get out and verify these costs with your suppliers and subs. To qualify for the credits, you actually need to have the building, when you submit, as of yesterday, your building permit requirement, you have to actually say on the plans and on this permit submittal how you're getting to the points. So you can't do this piecemeal as you move along and kind of get there at the end. You have to have all these decisions made up front so you can tell the permit department, this is how we're getting the 6 points. This third bullet we've had in there for quite a while now. It was a moving target last year, but now we know it's official. It went into effect yesterday. And we also recognize that, over a 90-minute to 120 minutes in the next couple hours, we're going to delve into this in as much detail as we can, but there is a lot of detail work. And so that's where you need to get your subs, raters, companies like ourselves that have been kind of living this for a while to help you navigate. So that's the caveat. So let's jump into section 1, which is the shell. So this gives you a good idea of some of the complexity of this. And I want to also introduce you to how we're running the rest of the presentation as well. So when we get to the section, we're going to have all the options listed out for you and their approximate cost and the credits that you get if you pick that one. What we've done also is we've put in bold what we think is the best or easiest or cheapest or most popular recommendation that we would have. So this was not only done from our recommendation, but we've done this enough times now that we've done some polling and gotten some feedback. And these are the ones that a lot of your partners in the trades are picking as well. So let's head through these. Kent, do you want to take us through first couple 3 and just take us through this table?
Sure, yeah. In the chat, somebody already asked about the window and doors. So there's a baseline table. It's the low-level bar that you have to cover. It's in table 402.1.3 in the code. You can get this code from WSU Energy online, and you can look up that baseline. This is all above the baseline, so you don't have to pick one of these. But in this section, you've got 7 choices here. You can only pick one. You see your credits in that 3rd column. So those are the credits you'll be taking depending on which section number you choose. The one we're recommending is the one that most builders are doing already under the current code, under the old code, I guess, not current anymore, is the U28 windows with R38 floors. And so if you notice on point 1.3 through 1.6, there's an option for a UA reduction. They've just published that online. It's a prescriptive path method. You enter in all your features of the home that affect the UA averaging, the thermal averaging, and that can determine if you can take a 5%, a 15%, or a 30% or 40% UA reduction. It does kind of align with the prescriptive measures that you'll see on those. So like in section 1.4, you're doing the R4 continuous insulation on the walls. So that's, you're doing your regular 2x6 framing plus adding foam to the exterior of the wall. And that's how you would get your one point on section 1.4. So you can get it with the windows. We've not seen a lot of U2O windows available yet. We have seen a lot of 0.24 windows available. We've been seeing those for several years now with a couple builders in our region. But the U2O windows, I think, are a little more challenging to get. They might get easier as they come. But for just a half a credit out of this section, that 1.3 is the best option. There are other methods. I guess we cover that in further slides, how to get some of these higher points out of this section, besides just adding foam board to the exterior. What else? Let's see, 1.7 at the bottom. It's using advanced framing with U28 windows, and then it's got a full R49. So that means you'd have to have raised heel trusses or really high truss joists to accommodate that. Again, it only gets you a half point. So we don't see many builders striving to get much more than 1 or a half point out of this section.
Yeah, so 1.4 to 1.6 are pretty easy to understand. You're getting better on the windows. So from a 0.28, 0.22, and let me bring up a quick spotlight here. So from a 0.28 to a 0.22 and a 0.18. And these, and 1.41 to 1.6 are all the ones that require some type of a continuous insulation package out on the exterior wall. So you're not only going from a 0.28 and R4 continuous insulation, but then you go to 0.22 to R12, 0.18 to R16. And this starts getting pretty spendy, as you can tell over here on the right. The same thing with 1.1 to 1.3. 1.1 and 1.2 are basically, you're just improving the window package. And 1.3 is the most commonly, a common window package is 0.28, the R38 floor. And then we're only going for half a credit here. I do want to quickly answer a few questions coming through on the chat. First off, yes, this slide deck is going to be available. There's actually this and a whole probably 5 or 6 different presentations that put together that will assist you learn some of these stuff, as well as 2 spreadsheets that are available to help you calculate this. They're all, we've made those available on our website at swiftshirenergy.com. You go there and it's basically the first paragraph. You click on it and you'll be able to download a zip file with all this information. So that's that. Hi, Nikki. It's good to have you here. These are based off of a 2,500 square foot house is what Nia did some of these calculations on. Mike, about your question about getting below 2.5. Yep, we agree with you. They are out there. That's why our recommendation is for right now to stay with 1.3, which is the 0.28 windows. There is a window coming online, and we got a picture of it later. It's called a thin triple, where the middle of the 3 is a really skinny, less expensive, less weight window, but it meets the criteria, and so that's coming down the road.
Question on the UA reduction. So that's using the baseline table, that 402 table, and then you're trying to get thermal reduction from that baseline. So if you get a 5% reduction from that baseline, you get to choose 1.3. If you get a 15%, then you're choosing 1.4. That's a prescriptive way. You list all your components into the spreadsheet, and that'll get you your UA average, UA reduction.
It's basically if you're going the modeling route, us as raters, we have a tool that we use. We take everything, we model it into the system, and at the end it comes out and tells us what UA reduction you've achieved. And so we kind of take the entire shell and come up with a number. Some of these are at a little bit, oh, there's an easy one. Thickness on the R4, R12, and R16?
Depends on the foam, but generally you're looking an inch per R5. So an R10 would be about 2 inches thick, roughly. There are we got some other slides that kind of show some other options here. Let's move on those.
Yep. Okay, so, oh yeah, here's the window picture. So there are windows out there that are down at the 0.15 and the 0.23. So we've got, they do exist. And here's the picture of that skinny triple. I've been told that this glass that they're putting on the middle of this thing is basically the same glass that they're using in televisions. And so you've got thick exterior, the thin, and then the thick again. It's helps in the weight and in the cost.
And the manufacturing, it fits the same framework that a double pane windows. So the manufacturer is easier for them to change their process. Those two windows on the left, those are ones we see around here quite a bit, the Ply Gym and the Alpine. There's probably other brands around, but we see these fairly frequently. Somebody asked if 1.7 is a bonus. It's not. It was when they initially rolled out with this program, but you can only take one choice out of section 1. So you can't take 1.7 plus 1.3. Here's a couple, here's some pictures of some different ways to get it. You got your SIPS panels. That's full panels. Probably most people are somewhat familiar with that. We don't see it very often. They work good on small boxy houses, but they're on custom houses. It'd be really tough and expensive. You got your double staggered studs. This is a good way to get the thermal break insulation. That way you don't have to put you don't have to put the continuous foam on the outside. The insulation in between the studs creates that thermal break, which is what how you get the performance up on that wall. The picture on the right is the sheeting layered with some foam board. It's only a half inch, so it's probably an R3. It says R3. Yep. So you got an OSB sheeting with a vapor barrier on it. Plus you've got the R3 foam on it. So it's a thermal break shear wall type of thing. The engineers for the seismic requirements prefer that over some of the other options. All right, there are different options too, but that's just a couple of them.
So here's where we are with our recommendation for section 1, which is to go with 1.3, which is the 0.28 windows and the R38 floors. A lot of people are currently doing this, and so that's why we've got the cost kind of static, is that there shouldn't be a lot of incremental cost for a lot of you to move to this. If you're not, I think the cost is fairly negligible to get to a 0.28 window. That's why we left it at there.
This question about interior floors. You don't have to insulate interior floors. We're just talking about the shell. This is shell components common to the outside.
Okay, well, we're going to move on to section 2. Section 2 is basically air infiltration, and it moves into kind of a quality check option as well. This is all about how your blower door results are coming out. So up until now, the code has been to achieve at least a 5 ACH, so 5 air changes per hour. So whoever's doing your blower door test needs to get it to 5. So going forward, the code hasn't changed. You can stay at a 5 and still meet the code. However, if you would like to get points out of it, you need to drop down to the lower section. So at the 3 ACH, you get half a point for that, and you'll need high efficiency vent fans. If you go below 3 ACH, so into the 2.2 and to 2.4, anything below 3 ACH, you start getting into the area where you need an HRV system to be installed. And so the tighter your house is, the more efficient the HRV system needs to be. So a 0.65 if you're going to be at 2 ACH, 0.75 if you're at 1.5. And if you're going down for basically a passive house at 0.6 ACH, you need an HRV at 0.80. So of course the cost gets more as you start moving to the HRV systems. And this is, we've kind of mentioned this is a quality area. So this is basically, a lot of people can get to these lower ACHs by simply doing things better, not necessarily a lot of money into them. This is about caulking better, sealing up holes, areas like that. We'll go into this a little bit more detail. So a caveat, this is something that we've been frustrated with, and we're trying to get the code to reflect in this. The new code requires that the volume get tested at a ceiling height of 8.5. But we know that there are a lot of you that are building 9 foot, 10 foot, 12 foot, 16 foot area ceiling heights in your homes. And there is a penalty that the house is supposed to be calculated based on an area of 8.5 feet. So there is actually a situation that may exist that if you build on a regular basis higher than the 8.5 foot ceilings, that you may need to, and you're shooting for that 3, you may need to drop below the 3 in order to get past this calculation issue here. The other thing that's going on is that based on jurisdiction by jurisdiction, the code is written so that it may be tested by an approved third party. So somewhere like a rating company to come in, somebody who hasn't been involved in the ceiling, the framers, the insulation, the HVAC company. It's got to be somebody else coming in and doing it. That's the kind of this third party quality check that's been put in. So this is an issue. We want you to be aware of it. We can definitely help you with trying to find out some ways through this, but it is going to be a challenge if you have a lot of vaulted or high ceiling areas of your home. This is going to be a challenge to meet that 3. Kent, any additions to that?
Yeah, that's just a catch that I think a lot of people might miss. So if you're shooting for a lower ACH number like a 2 or 1.5, you're really going to have to overshoot it unless you're already building short ceilings. If you're building 8-foot ceilings, this is actually a benefit to you. But typically it's a penalty for most homes.
Yep. Okay, another area that we see, some areas that we'd like to see you do, and these are basically the basics that we have on how to get to an under 3 ACH. And we've got this picture on the right just saying, you know, tools are meant to be used. Not everything looks like a nail. And there's lots of different ways through this. So 6-sided enclosures is a common area where we find that if there's 6-sided enclosure put in behind fireplaces, pony walls, tubs, showers, basically what happens is any vertical wall needs to be sealed on all 6 sides of the wall. So if you got the exterior wall, the stud cavity, you're putting insulation in there, and then you put right up against it a non-rigid material or a fireplace or a shower ensemble that has not been 6-sided enclosed. If you seal that up, we can help you get to 3 ACH, and I've got some pictures here as well. Seal material, we're going to show you how that can be utilized. We want to be seeing you use foam and caulking and then more foam after that. Some type of an air barrier and sealing checklist. We'll show you what that looks like. We want you to assign a champion to every project, every home. If you've got somebody looking at this, that makes a huge difference. And then third-party verification companies can help you figure out how to get there as well. So first, 6-sided enclosures. I described some of this. Kent, would you take us through the pictures?
Yeah, so this is a top view looking down on a fireplace in a corner. So typically the wall behind the fireplace doesn't get any kind of sheeting on it, which how you get a big advantage is you'd sheet that wall on the inside as well as on the outside. It acts like a good beer cooler where all 6 sides are enclosed. You know, you don't get the air. A better example is on your knee walls up in attics, especially for bonus rooms and garages. Everybody's probably built one of those where the customer complained that bonus room was too hot, too cold. It's never comfortable. They blame the HVAC guy. It's really not the HVAC guy's fault because of the construction method. You can see the 3 different, there's the top version is the typical method. It's got 3.5 inches of insulation exposed to the hot or cold attic space. A good solution is the next 2 sectionals through there. They sheet the whole bottom side of the rafters, and then they do their knee wall. And that that acts as a good thermal barrier, makes a good beer cooler. That's how we like to refer to it. And then the bottom, they sheet the exterior of that knee wall as well. So those walls perform a lot better when they're built like the rest of the shell, like your exterior walls. We've kind of been building them wrong over the years, and that insulation doesn't perform very well unless it's trapped within a cavity. I think that explains that kind of.
Yep. I want to show you some pictures of what we're talking about here. So here on the left here is a fireplace that's had rigid material put behind the fireplace. So instead of just looking at insulation or something that's just a film material, this is a rigid environment. So they've sealed off that insulation, and it's just a lot more effective. Here's behind a shower. So a lot of times what you'll see is this area behind a shower is just open insulation, and we just need a thin sheet of something rigid on the back. The other thing we like to do is we like to use sill seal as a mechanical way of sealing bottom plates and top plates. So you've all seen caulking be used to seal the bottom plate around the bottom walls, and typically what we'll do is we'll see it's the least your guy that you just hired. It's done at the end of the day. The floors are wet, and he's out there with several tubes of caulk trying to do it in this fading light on wet floors and trying to get a good seal around that exterior wall. And but by using some type of mechanical seal where you're not relying on the skills of the person, but you're actually putting a rigid material up against a rigid material with something foam in between, we find this to be a very, very inexpensive way to get a great seal. So what you see here on the right is this is an attic, open to the attic up here. This is before the drywall is coming up. And what they're going to do is they're just going to apply the drywall to these 2 walls. And then this is what it looks like from above. You see the drywall, you see the foam, and then you see the stud. And so you've got this mechanical seal that is going to keep the air. What happens if you don't do that is the air from up here in the attic can get down in the small gaps between the wood and the drywall, get down here into the cavity of the wall, and then they come out through the electrical plugs and light switches. And it's a very common way for air to travel. You wouldn't think it would be a much, but it makes a big difference. Go into a lot of houses on a windy day, put your hand up to the electrical outlets, and you can actually feel a breeze coming out of those. Let's see. Yep, and there's been studies done that we can get 1 ACH per 50 reduction by putting this type of material up. The other thing that we would highly recommend is having some type of an air barrier or sealing checklist. So this is one, there's several of these available. This is one that's released by the Energy Trust of Oregon group. And it basically is a checklist that you can go through on each home to just make sure everything's done. So they just remind your project manager to do all these things and make sure they're all done. So they look at penetrations, the recessed fixtures, all the blockings that are done, rough openings, everything. Have they been done and checked off before you get to the point where you can't go back and fix something? So Mike, is a gap between drywall and the wall? Yeah, it's there, and we found that for $30–40 worth of sill seal, you can do a 1 ACH drop. So as odd as it sounds, yeah, we do see that. So it's kind of caught everybody off guard, but we've noticed a big difference in homes when that's done. So some basics. Every home, so this is a good way to do it. Every home needs someone that's focused on air sealing. We like to say there needs to be someone assigned and everyone needs to be assigned. It's kind of an own your own hole area. So if you've made a hole in a wall, a lot of people will just go away and let's say, okay, somebody else will deal with that later. We've seen a lot of places where, you know, put a 3-inch plumbing pipe underneath a tub. They'll put in a 5-inch hole, and then whose responsibility is to make sure that gets filled in later. So and the other thing is we found it's easier to fix it mechanically than trying to fill in the gaps afterwards. That's this idea of sealing it versus caulking. Advanced taping of frames. And the other thing we like to do is what we call a blackout test or a smoke test. So if you send somebody up into the attic when it's dark up there and it's light downstairs, and you're just looking for before the insulation goes in, you're looking for everything that you see light, it needs to be caulked up. Smoke methods are a really good way to do it. And
you don't want to do that with fire sprinklers.
Yeah, water sprinklers you can't. Sprinklers you
fire
can't.
Sprinklers, yeah.
We highly recommend, and this is the area where companies like us get involved a lot, is we will come in and we can kind of look around and tell you pretty quickly ways to improve and work with you to improve this. It's pretty easy to get a home below 3 ACH. And if you want to go for anything more than that, we can help you get there. I want to mention really quickly, there is a product called Aero Barrier that is a fantastic product. It's basically they spray a silicon powder sealant that floats through the air. Same time, there's a blower door hooked up, blowing air in, and it basically flies around the house, finds any type of a gap in anything, and fills it up. It can sometimes take several hours, but you can basically go into a home and say, what ACH do you want? They'll just keep this thing running until it gets down to 0.2 ACH. And it's a company it's nationwide. They're doing a lot of business. If you haven't heard of them yet, you'll probably hear of them some point in the future. There is a new energy code label that whoever's been doing your blower door work is required to put on the panel or make available. This is so that the inspector sees that the work has been done. This new form is 10 times more complicated now than it was before. And there's a couple of areas that if the jurisdiction decides to enforce it, whoever's doing your blower door work has to have advanced equipment and knowledge on how to do this. So as you can tell, you've never had to have on the affidavit some of the system information that's here, and it all has to be filled out accurately but on the label. And then here's the areas I was talking about. There is a GPS and timestamp verification section on here that the jurisdiction may choose to enforce. This is starting to be a much bigger deal. They recognize that a lot of times a blower door test is just given a number and then slapped up there. This eliminates that option. So this may be new equipment for your testing company, whoever's doing that. And again, it's just jurisdictions may or may not enforce this. And so we want to make sure that you're aware of that. Can't we keep, we found some other new things on this form. Did you want to?
Yeah, so it's calling out for model numbers on a lot of the equipment. The ventilation on the bottom right-hand side, it's talking about the really paying attention to some of the details on the fresh air ventilation. Some of the commissioning, it's going to require some commissioning on the systems, specifically the HVAC systems. Yeah, it's just gotten a lot more complicated than it ever has been before. So we'll have to pay attention to that.
So as our recommendation for section 2, we are basically saying that 2.1 to go for a 3 ACH with a high efficiency vent fan and for half a credit is the best way to go. We feel that for less than $600 you can do this. It's not very much. This is really about quality. If you if you're not going for a higher, the 2 ACH or 1 ACH, if you really pay attention to some quality aspects of your build, you can get to 3 ACH fairly easily. The other thing is that we make this point down about this. The one thing you don't want to do, this isn't a decision that you can make and just spend money on it. You can't just pick an ACH of 3 and then ignore it during your build, because if you have put on your permit for 3 ACH and you're getting this half credit for it, and then at the end you get a 4, it's really, really hard to get that to make up that 1 ACH after the house is built. It has to be started at the framing and quality decisions as you go through. So this is what we basically say. This is not a purchase decision. You don't make a decision and say you're going to get to 3 ACH by spending money, except for aero barrier or something like that. Yeah. ACH is air changes per hour. Good question. I will try and do a better job on the acronyms. Thank you. Okay, heating system. This is a good one. So let's just jump through here. So we got a lot of pictures on this one to take you through. But basically, here's all the choices you've got. 3.1, stay with a gas furnace, you get a credit for that. If you jump to an air source heat pump at 9.5 HSPF, that's 1 point for that. If you jump to a 3.3, you get 1.5, and just down through this. There's basically the more money you spend on your HVAC system, on your air handlers and things, the more points you're going to get. Now, this is the one area where you can get extra points. So if you pick 3.4, so the ductless mini split heat pump with zonal electric, you thereby qualify on this table called 406.2 for an additional half a credit. So in other words, if you pick 3.4, you get to add 0.5 to it, so you get 2 points if you go with this one. If you pick one of either 3.2, 3.5, or 3.6. You then, on 406.2, you get an extra 1 point for the heat backup without electric backup. So let's jump into some of these pictures and we'll take you through this. So first off, here is the 406.2. Kent, I'll let you take this one through.
Yeah, so this they refer to it as the carbon emission credit. It's actually fuel normalization credit. So the less you're using natural gas, the more points you're going to get. So if you look at number 2 and number 4, that's where you get your positive credits out of it. The heating system with electric resistance, like a ductless mini split with cadet heaters, you'd be getting points with section 4, system type 4. The rest of the systems, your heat pumps often have electric heating strips in them, but if they're installed right with a lockout, then you can take a full credit. That number 2 system type, you can take an extra full credit on this carbon emission credit chart. If you're using wood heating, pellet stove heating or something, you get a negative credit effect on your choices there. But this goes along with table 406.3 and the heating system portion.
What we've come to and said that if 3.2, which is the air source heat pump, at $1,100, and then you add in the electric heat backup, that gives us points.
Well, the carbon emission credit, yeah. So you get.
Question about gas fireplaces.
So the gas fireplace is a different part of the code. It actually has some efficiency stuff in it, but it doesn't apply to the credit portions of it. It plays into that certificate, the label you have to fill out, but it doesn't affect. It's not affected with the points for the energy points. Unless you're using it for your primary heat, then it's probably an issue.
Hey, Kent, there's a question that's come up that I've never heard of. Question from Mike about a 320 amp electrical panel required for these. Have you seen anything on that?
If you got a really big house, you might need that. Yeah. For most houses, I don't think you would need anything like that.
So Mike, that might be something that we'd want to talk through at a later time. We've not seen that become an issue. Okay. So moving on to section 4, and this one's been fairly interesting as the years have gone on to see how this was developed. This is one of those areas where I think that the National Building Trades and the codes have finally had one of those aha moments and saying, when we moved ducts into the attic, what were we thinking? And it's that idea that you're taking the warm air and the cool air, and then you're putting it up into this area that gets really hot or really cold, and hoping a couple inches of insulation around a duct will keep it warm or cold. And I think now they're finally acknowledging that says, let's take all the insulation and then put our most expensive air in the house outside of that with a little wrapping around it to make it good. So there are now 3 options for you to do ducts. And so that's what we're going to talk about in order to meet one of these 2 point levels, the deep buried or the HVAC inside. And basically you can leave the ducts in the attic and the crawl space. And we're going to talk about the deep buried examples, and then we're going to talk about inside conditioned space examples. The question about electric on-demand hydronic inflow recirc systems, not in the code.
Well, it's basically under
That's
section
true.
3.3.
Yep, it
Usually,
is.
you know, if you're using a boiler or something like that, or a heat pump, then it might fall under one of the other programs. You'd probably have to get jurisdiction approval on some of those systems to be able to take points on it. Most of them would fall under section 3.3. Our chart here is really brief on the terminology. If you dig into the code, there's a lot more information, a lot more details on that.
Okay, so we're going to talk a little bit about heating design and duct location. So one area that we've realized that is going to help you a lot in your duct design is, given the fact that we now have a far superior exterior wall in the house that's got really good insulation, and the windows are really well insulated as well. This idea of running a duct out to the exterior wall and putting a vent either above the window or below the window and heating the air from that side of the house inward, we've moved away from that. And if you pull the vents into the interior of the house, your duct runs are a lot smaller. You're going to save money because there's less duct material being used, and you're going to have a better design system as it goes through. So that's one big thing that we would really encourage you to start looking at, opportunities, to shorten up your duct runs and not have these vents that are way out on the exterior walls of your homes. So that's one area we want to just mention right off the bat. Now we want to talk about deep buried ducts and what that means and looks like. It's basically an environment where we no longer hang the ducts up from the rafters. We drop them onto the top plate and then bury everything. And what you do is you get some maximums. You can have some of the equipment outside, so you can have an area where you put the air handler and some small amount of footage outside. And but most of it has to be on the inside.
Yeah, so the air handler has to be in conditioned space. If you're taking any points out of section 4, the air handler has to be in conditioned space. You can have some return air, some supply ducts outside of conditioned space, but it's real minimal. So keep that in mind if you're taking deeply buried ducts, that the air handler also has to be in conditioned space.
Now, we've seen a lot of creative ways of putting air handlers into conditioned space. So a lot of builders have been moving to putting a little closet inside the home and putting it in there. But we've also seen places where they've left it out in the garage, but then they've built a conditioned room around the air handler out there. As long as it's insulated and becomes part of the conditioned space, it's part of the conditioned space. But yeah, you have to have it inside somewhere, and we'll talk a little bit more about that. So another way to do this is with changing the structure of where you're putting your ducts. There's a few different options here. We see a lot more use of a conditioned attic. So this is spray foam put on the roof deck. And that's becoming more and more popular. And depending on your HVAC, depending on your installation company, you're either going to get a quote that's very expensive or fairly reasonable. The costs are coming down, and we do see where builders are starting to look at that as an option. It also makes it a little bit nicer for the homeowner because you can put some different access up into the attic and put some storage area, things like that up in there when you do a conditioned attic. Next option is very popular is to put the HVAC in between the floors and into the interior walls. So this is very popular with builders who have been doing high performance now for a while. They don't run ducts into the crawl and into the attic. They just put it between the floors, and that works out really good. Drop soffit is kind of going back to the way how you used to see houses back in the 60s or 70s, where you'd see a really obnoxious and odd, section of drywall in a room. But now we've gotten some ways to do that are designed in and look really good. There are sections, I don't have a picture here, we're going to talk about it in a minute, an attic coffin, which we actually don't recommend. And then this Oregon truss or modified plenum truss, this is basically where your truss has a space and then you put the drywall on the plate underneath it and block that in. So your insulation is still done like it is normally, but you've got basically two sections of a ceiling up here. You've got the top deck where the insulation is going to sit on blowing in just like normal. Then your duct system is in this area. And then you've got a ceiling section for drywall right here.
There's one item we don't have on here, Garen, is the conditioned crawl space. We don't see that much on the west side of the Cascades, but we have seen them a little bit more recently west of the Cascades. I suppose it'd be a better product where in the drier climates, but conditioned crawl spaces might be an option as well. You could run your ducts down into the crawl space that way, and you'd meet the conditions for that.
A couple pictures of what we're talking about. So here's the conditioned attic. Here's the attic coffin that what we talked about. This is essentially building a coffin. It looks like a coffin that your ducts can run in, and then this gets insulated around, and insulation is attached to this thing as it goes around the area. This is pretty difficult to do right, and there's a lot of issues around it. We put it on here for inclusion, but if you do go with this route, just be aware that you're going to run into some air sealing questions there. We see a lot of, over the last several years, both pictures on this, we see a lot of work on, and there are lots of builders, lots of framers, lots of HVAC companies out there that are very used to doing these. If your design has the space to do this, this is a really good option to get all of your HVAC inside. And we've loved this. Generally, your HVAC companies love it as well. They get to work on the inside. The trusses are better designed to do this. Couple slide for this plenum truss design. So here's two different plans of this plenum truss, and this is what we showed in another picture. So basically what you would do is your ducts would run in this area right here. You would have another layer of sheetrock underneath, and then you would insulate it like normal above. This basically brings your ducts within the conditioned space. Here's another design for the same thing. And of course, on the right, we've got an air handler inside of the home. This is becoming very common. The issues of hearing the air handler run have been mitigated with insulation. If you do your air returns properly sized, you can eliminate whistling noises and things like that. If you haven't built like this yet, I'd encourage you to look at doing this either in the footprint of the house, a conditioned space outside, or a conditioned area up in the attic is fine as well, but it just needs to be within conditioned space. And in order to get that extra credit, you do need to have this on the inside. That is part of the code. So our recommendation, just based on the extra point it gets and how easy it is to get there, and we've just seen a lot of builders over the years already move to HVAC inside, is to go ahead and look at making the jump now and bringing it inside the conditioned space. We do see some success of doing it deeply buried, but the extra work it takes to get the extra half point is pretty minimal. So that's our recommendation at this point. Water heating. Okay, so there's several areas here that we can go through. So a lot of folks are looking at 5.1, and so we wanted to talk a little bit about the 5.1. If you choose to do 5.1, this is one area where you can get two lines on the same one. So if you do put in drain water heat recovery units, you can add the 0.5 to the other sections and get a higher point value. Now, the drain water heat recovery unit is basically you're putting off of every source of hot water coming out of a drain. So this would be sinks and showers. You basically put a recovery unit there, which recirculates the heat of that water back into the hot water system. We have not seen anybody doing these yet. A lot of the plumbing companies are not anywhere ready to do this. So we haven't seen anybody headed that direction.
Yeah, a little difference there. It's mostly off tubs and showers. It's not off every sink or anything like that. So your main drains, your tubs, showers, a lot of those tie in anyway to the same drain line. So on the tub showers is where you'd have to have those heat recovery coils or setups. The gas water heater, we have seen several builders looking to stay with the on-demand gas water heaters, but they're having to make up, they're losing about a half a point. They're coming up about a half point short. So some of them are having to go with solar or stepping up on their shell components to be able to meet the requirements. But customers love the on-demand gas water heaters, and I think some builders recognize that, so they're trying to find ways to make that work. What
So
else we got?
Let's just kind of go through some pictures. We've got pictures of a lot of these, Kent.
Yeah. So here's a kind of a cross section of a heat pump, real simple one. Heat pump water heater. You got your coil and you got your pump on the top. And then the one on the right is your split system water heater. They are available. They're a little expensive. I think it reflects that on the charts. But it's got your compressor outside of the building. You know, it extracts the heat from the air. And when you've got one of these heat pump water heaters in your garage, you get complaints of the garage getting too cold. So that the one solution is put the compressor outside like you see on the right. These are really efficient as far as energy use goes. It's like 300% efficient. It means you put $1 in, you might get a $3 worth of heat out.
Ready for the next one?
Yep. And you got your gas on demand. We see a lot of builders still wanting to stick with that process. Geothermal heating, it's usually combined with your hydronic heating system as well as your water source, water heating. You got your solar panels. We're not seeing anybody go with the solar water heat. We have seen quite a few of the geothermal systems going in, even on some small lots. So there's some ways to get these geothermal systems on, 8,000 square foot lots. It's pretty amazing what they're doing now with some of these. Next. So the different tiers on the water heaters, it's basically a performance. So tier 1, tier 2, tier 3, there's actually a tier 4 category too. If you're taking tier 3 or tier 4, you get the higher points on the credits. They're generally better performing, better water heaters. I haven't seen anybody really leaning towards taking a tier 1 or a tier 2 water heater. They're either going with the on-demand gas water heater or with the tier 3 electric water heater.
So if you're kind of keeping track, we have now gotten to 6 points with where we are through here. So this becomes our recommendation for achieving the 6 points at the easiest and the most cost-effective way. So we're going to go through the next 2 sections to show you what those are. If you don't want to use these, we want to show you the solar and the appliances. And then we're going to show you some other tools that you can use to make your own calculations.
Yeah, we're not saying this is the only way or the best way or anything like that. It's the one that we're seeing most common. It probably is about the cheapest way we've seen, but it really depends on your suppliers and the people you deal with. You know your own business better, your own business model, who you're marketing to. So some markets it wouldn't be quite a fit.
So let's move on and talk about section 6, which is solar. Basically, the more panels, more kilowatt hour panels that you put up, you can get more points. So if you have a customer or if you have a branding message around putting in solar, you can rack up some pretty good points fairly quickly, but at a cost. Basically, every 1,200 kilowatt hours of solar panels that you install is going to cost just about $5,500. So you can quickly rack up a fairly high point here, but I think they did this intentionally. If you do want to go solar, you're going to be rewarded in the points. So there are 3 points available here if you want to use that. The appliances section is really interesting to us. They basically put a method to get another half credit for using Energy Star appliances. So this would be a situation where you're putting in your own Energy Star appliances, including the washer and dryer, and the dryer needs to be a ventless dryer. So this is a technology that is really popular in Europe. It's really popular in Europe in small living, so 1,200 square foot or anything like that. It's basically what you would be required to do is you would be required to build a home that does not have an external dryer vent, nor could it be a dryer vent put in there and then you put a plug into it. There's just no dryer vent as well. Then you would be required to dictate to your buyer what type of a dryer they're using, which is this dryer. And right now the technology is just not solid. These are meant for a couple a few things in the laundry at the same time. It can sometimes take an hour or two to dry clothing.
Yeah, the technology is good. It's just that it's not meant for big families or large loads of clothes. So it's going to be a great program for your multifamily type stuff where there's only one or two people living in a place, but probably not a very good option for most single family residential homes unless you're building the small ones where you only got one or two people living there. It might be a really good option for them.
So that's that. Just based on that, we didn't feel like we could. And there's been some builders who have come and said, "Hey, we'd like to use 7.1 in order to get there. And what does it take?" And it includes this ventless dryer option. And as soon as we've explained that to them, they've said, "Oh, 7.1 doesn't make a lot of sense."
It's a good option for apartments, townhomes, maybe. That's about it. So what's the next slide we got?
So what we've done is between two different firms, two different spreadsheets have been developed, and I'm going to be providing you both of them. So we created a table, a spreadsheet several months ago, which allows you to go through and it basically has the various options, the credits associated with it, and then if you just apply the credits available in each one of these areas, it will add up that amount up here at the top, and you can kind of make an informed choice, seeing 3 or 4 options at the same time on the same sheet to get to the point. So it will automatically calculate, the 6 points, the approximate cost, and let you kind of weigh the pros and cons. So this has been created. We're going to provide this to you, and you can make use of this. In addition, NIA has built, and Better Built Northwest, the folks there have put together a really nice spreadsheet, and I'll show you the 2 sections of it. They've basically gone through and done something very similar, where they're saying, here's the cost and what you're going to get out of it. And they actually have an area where you can kind of say, what's its cost per credit? So this is $1,400 to do it, the average cost, but it's cost per credit, so it's actually being valued at there. So it's a good way to let you do very similar. The other thing that it does is they have applied a complexity scale to it. So in terms of sequencing, material sourcing, durability from an indoor air quality and the benefits there, code concerns, and ease of implementation score, they have said which ones of these are, very hard to do versus very easy to do. And it has a nice little score over here that lets you very quickly say how hard and how easy is this to try and work into existing processes. So I want to show 2 slides of way too much information. I'm not going to go into these in any level of detail, but we ran up 4 other ways that you can get to the 6 points at various cost levels. So this one here, the first one you're looking at is the one we've already talked about. That's our getting there via that area. The one down below is kind of a solar option if you wanted to go with just a minimal solar option. So this is if you're branding yourself or if your customer is asking to have some type of a solar environment, but they aren't going really big on the solar. It's a way to get to the 6 points there. I can't, again, yeah, solar again there on this top one here is if you're gonna go big time on the solar. I can't remember what's this, this is if they went advanced framing. That's right.
Yeah, it's just picking a different shell option. Then it's going with the 11 HSPF heat pump. It's jumping up to the 2 ACH for the air leakage. And it's just another way. That's actually, I've seen several builders going that route. Some of the HVAC components are really getting advanced. We're seeing some mini split heat pump options that actually distribute air. You know, your Bryant and your Mitsubishi have really got some great products coming out. They're probably best suited to mid to smaller sized homes. Your really large homes, you'd have to have multiple systems in. Of course, you have to have that anyway with the really large homes.
We're getting some questions.
There's a lot of different ways to get there. You have to find the one that fits your own business model.
Just responding to some of the things coming through on chat, Tom. I agree. I think there's going to be a lot of movement to the lower cost options. We just wanted to be for inclusiveness. Have some other options out there. Adam, I actually, Hans, yeah, we know some of these costs they're just estimates, and what we got through initial reads, checking with lots of suppliers, and also talking with builders who have already got them. So that's why we've said, I mean, every time we've got this asterisk up here and just say these are estimates, you need to go out and get your own accurate costing. So that's very good points.
Yeah, the feedback we get is it's too high, it's too low, but you know, it's really falls on each company to figure out what their actual costs are.
Correct. Yeah, costs are not our accurate point. So the other thing we're doing is I'm going to provide as many of these areas. I've got a presentation about 5 good ways and 1 bad way to get your ducks inside, ducks in the attic, deep buried ducts. I've got some presentations going out on that. There are several raters probably on, there might be some raters on the phone with us today. They're a great resource to go. We are as well. And then there's these 3 good links that you can get to, and this will all be in the deck, and I'll be in the material, as well as to get to links of other resources that can help you wade through these things. So a couple of things on the good news side. So I don't know if you have heard of the 45L tax credit. So this tax credit has been around for quite a little while. And it basically what it says is if you meet a certain level of criteria, including being a certain percentage above the national building code. So it doesn't have anything to do with Washington's buildings codes. It's the federal code, which is a lot different, especially as of today or yesterday. There's a huge difference between Washington's minimum code and the rest of the country. This means that a lot of homes, if you study this and you get a 45L tax credit form done on your home, you can actually apply for and get a $2,000 tax credit. So this is not a deduction. This isn't a straight off credit on your taxes, your company taxes. for building and selling energy efficient homes. It's not a one-time deal. If you build 100 homes, 100 times $2,000 each starts adding up very quickly. This got renewed through the end of, it's always generally put in to the previous year. So the 45L that's out there right now is good for homes that were built before a month ago, before December 31st, 2020. It's been renewed every year for
Since 2005.
Yes, 15 years. It's been out there. No matter who controls Congress, it kept getting renewed all this time. We fully expect it will be renewed again for homes built in 2021. But some of the times we won't know until next January or February timeframe if the rules got changed or if it's got approved. So that's just like everything in taxes, right? You don't ever find out about it until it's sometimes too late. But we're pretty confident we know what it is, and it's pretty easy to get to. Oh, I thought I had a slide for how. Oh, I got it out of order. So here's how it works. Basically, from a energy rater who's done a HERS rating on a home for you. The HERS rating is required for this to occur. One of the reports that comes out of the HERS process is called the 45L tax credit documentation. And it comes up with a line here. This home meets the requirements for this credit. Then you have your CPA or your accountant or your bookkeeper fill out a simple form, 8908, which basically says how many homes did you build, multiply it by 2,000 and submit it. And you'll take a $2,000 tax credit per home on all your houses. Drop back one slide. So these are some of the things that we offer as a company, and a lot of rating companies around offer the same type of thing. We do it better. No, I'm kidding. We really act as an independent quality team for your subs. So we're the ones that will come in and work with your subs and kind of be that person who monitors the quality level throughout your entire build. We help you get the incentives and the tax credits. We help with something we call EDA or early design assistance, consulting, third-party verification. We offer certifications in NGBS and a lot of these things that were listed here. So what I would suggest is a few steps. Is first off, go to swiftssureenergy.com. Right up at the top banner is a link that you go to a second page, you fill out your name and your email address. You get a download right there, a zip file that has this deck, the spreadsheets, and the other files that are there. Then you need to confirm all the pricing with your suppliers. So a lot of comments that we've got coming through have said that our costs are high or low. They are high or low. We don't know. You need to find out what that is with your own suppliers. We really encourage you to get a third-party verification system in. We think the code is headed that direction. It's definitely there now. And then we would think that if you add this HERS rating to your home, that you can get the 45L tax credit coming. We're pretty confident with if you do this right, you'll at least get that tax credit come back in. It kind of mitigates some of the pain that's being affected by this. Next thing I want to just really quickly talk about is a new opportunity that you got for this and marketing your homes. So there's been a lot of press out about the new codes, how much they're doing from a costing perspective. But I need to let everybody here know that these homes that are being built with better energy efficiencies, they also meet all the criteria that are out there for a healthier home as well. So monitoring where the fresh air is coming from in a home, and keeping the garage separated from the house so you don't let any of the fumes or toxins from the garage enter into the home. All those types of principles are all within the energy efficient home. So you can actually use this as a marketing method when you're working with builders, especially if the builder next to you is not saying that they have a better healthy home and you are. That's one more tool that you've got in your toolbox to sell homes and show their value as well. So I want you to just keep in mind that that's out there. We've already been involved in a cultural shift towards the environment. This is just taking what's happening with the codes, especially this energy code in the state, taking advantage of that as a marketing tool to sell your homes and differentiate your home from your competitor, especially after the year we've just come out of with the emphasis on health and how to stay healthy. So good opportunity. Again, a quick mention about who we are, where we can help you guide through this. We can help you figure out how to get through the energy codes and really help you with the where you're going. We have offices in Vancouver and in the Tacoma area. Here's our contact information, both Kent and myself, and then Tim is our person in the South Sound area. We'd love to chat with you more and see what we can do to help you. That's kind of that's the presentation for today. If there's other questions that people want to ask, we can ask in chat. We could, if you've got a time, we could open up the line. But Kent, do you have any additional things to add? Oh, somebody's asking about accessing the slides on your site. Okay, let me just bring up the website.
So there's a link on the landing page. Just click on that and it'll download. You can download.
You have to enter, so here's SwissYourEnergy.com. If you click on provide the pathway options, so I've already come through, yeah, you basically enter your name, your email, and your company, and that will give this button right here will change to download at that point. And so you just download it at that point. And I updated it this morning, so if anybody has problems with what I did, please let us know as soon as you can. John, did that help? That was your question about accessing the slides? All right, perfect. Thank you. Kent, anything else to add?
Yeah, Chuck's asking a question about heat pump combination with a with a furnace. Our understanding is if you're using the heat pump primarily and the furnace is just a backup, then you should be able to get points for it for the heat pump versus the gas furnace. But I think that's going to come down to a jurisdictional decision, probably. I know if you had a lockout on your furnace, it might qualify. So I don't know. That's come up a couple times in the questions. Yeah, heat pump with hydronic system. should work, depending on the performance of the heat pump. And I think, no, Hillary said maybe somebody from the west side was going to jump in the last few minutes. Is that still the case?
Say that again, Kent.
Hillary said
Unfortunately, no.
Oh, okay. Yep. All right. Well, I think that's all we got then.
Yep. All righty. Thank you, everybody. We would love to hear from you. And if best of luck in 2021. We're hoping for great things in the building industry and for Washington State. So if we can be of any service to you, please get in touch. And if you have any feedback, you want us to do, you would recommend anything to do differently next time, please let us know. And also just a call out to the BIAW as well as Olympia Master Builders. They were the sponsors of this. And we really appreciate Hillary and Al for sponsoring this for everybody. There's another session next Tuesday. Hillary, how do people find information about that next session?
Yeah, so you can email me directly. I'll put my email in the chat. Or if you go to BIAW.com on our events and classes page, there will be information on there.
Okay, super. All righty. Thank you, everybody. Have a great rest of your Tuesday.